Hello students, I am here to teach you chapter 9 in your textbook that's called Triangle 2. So we learn more about triangles. Now can you remember in chapter 1 I explained there are 3 types of triangles. What are they? Can you remember? We did 3 types. All sides are equal and all angles are equal to 60. What you call that? That's called equilateral triangle. What about the second type? All sides are different and all angles are different. So we can say A, B, C. What you call that? Scalene triangle. What's the third type? We did a triangle with 2 sides are equal. So what we called it? Isosceles triangle. And we know if the 2 sides are equal, these 2 angles also equal. Now in this chapter, we are finding more about isosceles triangle. So we'll take an activity. We want to find out properties of an isosceles triangle. For that, we'll take any line that you like and any length. So I'll take AB line. You can take 7 centimeter, 5 centimeter, any length. Then I want to measure 70-degree angle and draw a line. And then what we can do, take the same length here and mark the point C. So now we have 3 points. Now try to connect it. Then what you have to do, try to measure these 2 angles with a protractor. When you do that, you will get roughly 55-degree angles. So what can you say about that? When these 2 lengths are equal, these 2 angles should be the same. So sometimes you get approximated value. That's okay, but both these should be same size. Now let's take an isosceles triangle. These 2 sides are equal. So here what you call this? This is the angle in between the equal sides. If you want to identify this side, what you call it? This one. We can say opposite to the equal side. So here let's label this as ABC. How can I write this angle? So here it's really easy. If you want to find out the opposite angle to this one, what you do, you write the line with a gap and include the other point inside. So what's the angle opposite to the equal side? Opposite to AB, we can say ACB. So we can write angle opposite to AB. Now, how can we write angle opposite to AC? So, AC line is there, so you write AC with a gap and include the other angle, letter, ABC angle. So, what is ABC means? Angle opposite to AC. Now we'll take what's the angle opposite to BC. So here write BC and you can include the angle in between. So BAC angle. So is the angle opposite to BC. So to identify the properties, we need to know first what are opposite angles to equal sides. Now we'll take the Theorem 1 in your textbook. So here this is about isosceles triangle. It says if two sides are equal in a triangle, the angles opposite the equal sides are equal. So what it means? So when you take a triangle ABC, two sides are equal. And we want to find out these opposite angles to equal sides. So what is the opposite angle to AC? That's B. What's the opposite angle to AB? That's C. So according to theorem, it says B angle and C angle both are equal. Now we'll try to prove that. So let's take ABC triangle, but we don't know these two. So here we need to do a construction. Here you are drawing the angle bisector from A. So that means this angle is equal to this angle. So what you want to prove? We want to prove that ABC, this angle is equal to ACB. So we need to do a construction. We are drawing angle bisector let's say AD. So we are drawing angle bisector AD. Now we have to check whether these two angles are equal. So here I'll erase this one because we don't know whether these are equal. So here now take these two triangles. What are the two triangles? So here for the proof we can take ABC, ABD triangle and ACD triangle. In that triangle we know AB side is given equal to AC. That's given as data. That's given. And also we know AD is a common side. And also this is an angle bisector. BAD is equal to DAC. What can you say about these two triangles? You have this length, and this is the included angle. So this is the included angle given. So what can you say? According to this side, two sides and one angle given. So we can say ABD triangle is congruent to ACD triangle. So what happens if these two are congruent? Corresponding elements are also equal. So what are the corresponding elements? Opposite to AD, the angle is B. Opposite to AD to the other angle is C. So that's why we can say ABC angle is equal to ACB angle because those are corresponding elements. So here we can apply this theorem. What is the theorem? It says in a triangle, if two sides are equal, the opposite angle to the equal sides also equal. So we'll try to apply this in examples in future. Now we'll take theorem 2. It says converse of the theorem on isosceles. What is converse means? The opposite. We'll take a triangle. Now the given information is two angles are equal. So how we identify the opposite side? Opposite to this one is this one. So here if you take ABC triangle, what is the opposite side to angle B? What can you say? Opposite side to angle B is AC. What can you say about this one? What is the opposite side to angle C? AB. So first thing, before we find out the proof, you need to identify what are opposite sides to angles. So now we'll try to prove this theorem. This is converse of isosceles triangle theorem. Now we'll take ABC triangle again. What is given now? You have given two angles are equal. So we can write ABC angle is equal to ACB angle. So that's given. What you need to prove? You need to prove the length AB is equal to AC. So here also we need to do a construction. So we'll do a construction. We can draw the angle bisector from A. We'll call it AD. So we are drawing angle bisector AD. So angle bisector means this angle is equal to this angle. So here what can you say about these two triangles? Now you get two triangles ABD and ACD. We know AD is common. And also we know ABD angle is equal to ACD angle. What's the other information you know? You know BAD angle is equal to DAC angle. Now what happens? Side and angle and another angle. So what can you say? Any two angles and one side, we can say two triangles are congruent. So we can say ABD triangle is congruent to ACD triangle. If these are congruent, what can you say about the corresponding elements? We can say, look at carefully, the corresponding elements means if you take this angle, opposite to this angle is this length. So we can say AB is equal to, opposite to this angle is AC. So why this is true? Because these are corresponding elements. So here, what is the theorem number 2 says? When there's a triangle with two angles equal, the opposite side to that angle is also equal. Now we'll apply these two theorems in examples and exercises. We'll take the example number 1 in your textbook. So it says there's an ABC triangle and AB is equal to AC, already given. And it's given ABC angle is 50. Find the magnitude of ACB, this angle. What type of triangle is this? We see two sides are equal. This is an isosceles triangle. So here according to theorem number 1, we can say the angle opposite to equal sides are equal. So straight away we can write ACB is equal to 50. That's theorem number 1. Angles opposite to equal sides are equal. Now we need to find out BAC. What is BAC? The other angle. How we find out the other angle? So we know the sum of interior angles in a triangle is 180. So here we can write, if you can put x here, x plus 50 is 180. So how can we find x? So we can find x as 180 minus 50 and 50 becomes 100. So you take 100 to the other side. So what's the answer? You get x equals 80 degrees. So what is x there? BAC. Now we'll take the second example in your textbook. It says in the triangle ABC, AB equals AC and ACB is 40. Now we'll try to draw this triangle. There's a triangle ABC. AB is equal to AC. ACB is 40 given. The point D has been marked on the side BC here such that AB and BD and AD has been joined. Okay, so here this is equal, AB and BD. So here we'll mark here somewhere. So it says this length is also equal. So they are asking, find separately the magnitude of each of the angles in the triangle ABD. So we need to find this one and this angle. So how we can start? Now can you see when you take ABC triangle, two sides are equal. So if this is 40, this angle also 40. So you can straight away write ABD angle is 40 according to the isosceles triangle. So here, if this is 40, now think about ABD angle, the triangle. What can you say about that? This side is equal to this side. This is also an isosceles triangle. So what we can do, we can write y here. Both are equal. So in ABD triangle, we can say 40 plus y is equal to 180. So what is 2y? You can take 40 to the other side. 180 minus 40, you get 140. When you divide by 2, you get 70 degrees. Now we found out this is 70 and this is 70. So now we have all angles in ABD. So what are those? We can write ABD angle is 40 degrees. BAD angle is 70 degrees and BDA angle is 70 degrees. Now we'll take the exercise 9.1 in your textbook. So you have given several diagrams and ask you to fill the blanks. Okay, so 2 parts are already done. So you have to start with ABC. So we'll check whether all pairs of equal sides given. PQR, yeah, 2 sides equal given and the other one 2 angles equal. So here this and this. Second part also done. ACD triangle. These 2 lengths are equal and these 2 angles are equal. Now we need to fill this one, ABC triangle. In ABC triangle, what can you say? What are the 2 lengths equal? AC and BC. What are the angles equal? We can write these two angles, CAB and CBA. Now the next one, KLM triangle. So the big one. So what are the two equal sides? KL and KM. What are the angles equal? If these two lengths are equal, we can say KLM angle is equal to KML angle. Now what can you say about the other one? LMN. That's the smaller one. So it's given LN is equal to MN. So what are the two angles equal? We can say that these two angles are equal. NLM and NML. PQR triangle in this one. So you have given these two lengths are equal. PR equals to PR and QR. So no need to write. Here we write comma. And here what's the angle? Equal this angle and this angle. So here QPR and RPQ. Next one, RST. RST, we can say SR and TR. What's the angle? Equal angles. Here we can say this and this. So we can say RST angle here. RST angle and RTS angle. So the next one, ABD triangle. This one, what are the two equal sides? AD and BD. What are the equal angles? This angle and this angle. We can write DAB angle and DBA angle. Now we'll take this triangle, BCD. That's this one. So BCD, what are the two equal sides? BDN. I'll write here. What are the two equal? BDN, CD. What are the equal angles in BCD? This one. So if these two are equal, we can say this and this angle. So here DBC and DCB. Now we'll take the next one, ABC triangle. That's the larger one. So here, what are the sides equal? We can see AB and BC. So I'll write here this one, AB and BC sides are equal. What are the angles equal in ABC triangle? This one and this one. So we can say BAC angle is equal to BCA angle. This and BCA angle. Now we'll move to the second question. So in the second question, you have given three diagrams there. You are asked to find out magnitude of other two angles. Okay, so this is given as isosceles because two lines are given equal. So that means straight away we can apply the theorem, opposite angles also equal. So here what can we say about this angle? This is 75. So we can straight away write ACB angle is 75. So what about the other angle? We know the sum of interior angles in a triangle is 180. So how can you find ABC angle? We add these two and subtract from 180. So what is 75 plus 75? We get 150. So we can straight away write 180 minus 150. You get 30 degrees. So this angle is 30 degrees. Now we'll take the next diagram. You have given 80 there. But we know these two sides are equal. So we will put, if this is x, this is also x, according to the theorem. If these two are x's, we know the sum of angles in a triangle is 180. So you can write 80 plus x should be equal to 180. So 80 plus x becomes 2x is equal to 180. So take 80 to the other side. 2x becomes 180 minus 80. That's equal to 100. So what is x? You divide by 2, you get 50 degrees. So now you found this is 50 and this is 50. So we can write ABC angle is same as ACB angle. That's equal to 50 degrees. Now we'll look at the next one. So this is also an isosceles triangle. So we can straight away write down if this is y, this is also y. Now we know this angle is 90. So sum of angles in a triangle is again 180. So we can write 90 plus 2y is 180. So what is 2y? 180 minus 90 becomes 90. So y becomes 90 divided by 2 is 45 degrees. So what we can write? RQP is equal to RPQ is equal to 45 degrees. Now we'll see these three questions. Find the value of each of the angles denoted by an unknown in the following. Now we need to find all these unknown letters. So first take a look. Can you see in this triangle these two lengths are equal, and also this triangle these two lengths are equal. So we'll try to fill with letters and then identify what are the angles. Now when you take the big one, it's a right angle triangle and this is 41 given. Straight away you can find x. So we can write x plus 41 plus 90 degrees is equal to 180. Sum of angles in a triangle. So x plus what you get here 131 is equal to 180. X equals 180 minus 131. So subtract 10 minus 1 is 9. 7 minus 3 is 4. So 49 degrees. Now we found x is 49. How can we find out the other two letters? Now if this is 49, we can see this is also 49 because this is an isosceles triangle. Now look at this carefully. Both these two angles add up to 90. You can easily find out the y value. So here y plus 49 is equal to 90 degrees. So how you find out y? You subtract 49 from 90. So what's the subtraction? 1 remaining, 5 and 4. So 41 degrees for y value. So here this is 40. Can you see without doing that, this is also isosceles triangle. Easily you can apply the theorem. Now how you find out the a value? In this triangle, we know this is 41, this is 41, you can find a. Or can you remember previous theorem in chapter 8? The sum of opposite angles is equal to exterior angle. So here you can use that one. So A is equal to 49 plus 49. So 98 degrees for A. So here we found all three angles. Now look at the second one. Now look at carefully. It's given this length is equal to this length. So if this is A, we can write this is also A. Again, if you take this triangle, this is P. So this should be P according to the isosceles triangle. Now, can you see these two add up to this one? So what's that? Opposite angles add up to the exterior angle. So we can write 2P equals 140. So what is P value? 140 divided by 2, you get 70 degrees. Now we found P. Again, when you take the smaller one, can you see double of A is equal to P? Again, exterior angle is P. So we can write 70, that's P equals double of A. So how you find out A? We divide both sides by 2. 70 divided by 2 is 35. So we get A equals 35 and P equals 70. Now look at the third part. So here we have to find out D and A. So here we can see this triangle, these two lengths are equal. So we can write this angle is 80. So in the smaller triangle we can write 80 plus D equals 180. That's the sum of angles in a triangle. So how you find out that? 80 plus 80 is 160 plus D equals 180. D becomes 180 minus 160. That's 20 degrees. Now, look at this angle. What is this angle? This should be 100. Why? This is a straight angle. So, if this is 100, what can you say about the other angle? And also, this side is equal to this side. This is same as A. So, we can write the sum of angles in a triangle. 2A plus 100 is 180. Or we can write 2A equals 180 minus 100. That becomes 80. A equals 80 divided by 2. You get 40 degrees. Here there's another method. So, without finding this one, can you see double of A is straight away equal to 80. That's the exterior angle. So, you can use that method as well. So, what's the answer? A equals 40 and D equals 20. Now, we'll take the next part. So, in this triangle, you are asked to find out M and N. Here, when you take this triangle, these two lengths are equal. So, definitely this becomes 40 degrees. This triangle, these two lengths are equal. So, this should be equal. So, straight away you can write M is equal to 30. So, how can we find out N? So, here this is 40, this is 40. What should be this angle? You can use sum of angles of a triangle is equal to 180. So, we can write M plus N plus 40 plus 40 is equal to 180. So, M we already know that's 30. 40 plus 40 is 80. So, you get N equals 180 minus 80 plus 30, 110. So, 180 minus 110, you get 70 degrees. So, we found M and N. Now, look at the next part. So, here, these two sides are equal. So, that means if this is F, definitely this is also F. So, how can you find out using the triangle? we can say 2f plus 70 is 180. That's the sum of angles of a triangle. Subtract 70 from this, you get 180 minus 70 becomes 110. 2f is 110. How you find out f? 110 divided by 2. So you get 55 degrees. Now how can we find out E? These two lengths are parallel. So here, if this is f, can you see this is also f? And also, if this is E, this becomes E. Why? What's the reason? These two lengths are equal. This is an isosceles triangle. Now, we can form an equation with this 180 degree angle, straight angle. So, we found f as 55. So, we can write 70 plus 55 plus E is equal to 180. So, how you find out E? So, add these two together, you get 125 plus E equals 180. E equals 180 minus 125. You get 5 here, 5, 5, 10, 3 remaining, 55 degrees as the E angle. Now, let's take the other part. Now, in this triangle, this length and this length are equal. If this is T, this should be T. And these two lengths are equal. If this is 75, this is 75. So, what can you say about this one? So, this is the exterior angle to this triangle. So, straight away you can write 20 plus T is 75. What is T? 75 minus 20 is equal to 55. Now, you found T value. So, how can we find out the U value? Can you see in this triangle, 75 is the exterior angle. So, we can write 75 equals to U plus T. So, here you found T value. So, substitute here and you can find out the U value. So, what is U value? U is equal to 75 minus 55. You get 20 degrees. So, we found both the two angles. And there's another one, G angle. So, how can we find out G? So, we can look at this triangle. So, these two, 75 and 75. So, you can easily find out G. So, here what we can write? G plus 75 is 180. That's the sum of interior angles of a triangle. So, you can write 75 plus 75 is 150. So, G equals 180 minus 150. You get 30 degrees. So, we found G value, U value and T value. Now, we'll look at the next question. So, question number 4. In a certain isosceles triangle, the included angle of the two equal sides is 110. So, shall we draw the triangle? So, there's a triangle isosceles, so that means two sides are equal. The included angle of the two equal sides. This is the included angle that's given 110. Find the magnitudes of the other two angles. So, you are asked to find out these two angles. So, we'll take this one is x. So, this also x. So, we can write the sum of interior angles add up to 180. So, how can you find x? 2x equals 2x plus 110 is 180. 2x equals, take 110 to other side. 180 minus 110, you get 70. So, 2x is 70 means x value is 70 divided by 2 is 35. So, they ask what are the other two angles, that means 35 each. Now, we'll move to the next question. So, you have given a diagram. The point O lies within the square ABCD such that AOB is an equilateral triangle. So, this is given equilateral triangle. So, all sides are equal. find the magnitude of DOC. DOC is this angle. So how can we start? We know all these angles are 90 degrees. So here, this is an equilateral triangle. So this is 60, this is 60, and this is 60. But we know in a square, the angle is 90 degrees. So what is this one then? This is 30 and this is 30. Now here, we want to find out this angle. Now try to find out this angle. So here, this is 30. Now look at this diagram. Now this is a square. We can see these all sides are equal. So here we can mark all these sides are equal. In this triangle, we know these two are equal. So how can we find out these two angles? So we can say this is, you can write this is x or something, write x. So 180 is equal to 2x plus 30. So what is x? 2x equals, take 30 to the other side, 180 minus 30 becomes 150, x becomes 150 divided by 2, that's 75 degrees. So we found this is 75 degrees. Now what about other side? We know this is 30. So these two sides are equal means we'll take y as this angle. So how can we find y? We can say 2y plus 30 is 180. So take 30 to the other side. 2y equals 150. Y equals 150 divided by 2. You get 75. Now we know x is 75 and y is 75. So here this is a point. What's the angle around a point? That's equal to 360. So we can write x plus y plus 60 plus the angle we need to find, that's COD. That should equal to 360. So what is this angle? We know x is 75, y is 75, and we can add it together. So here you get 75 plus 75 is 150. 150 plus 60 is 210. You can subtract 210 from 360. So what you get? You get answer as 150 degrees. So COD angle is 150 degrees. Now we'll move to the sixth question. In the triangle ABE, while A is an obtuse angle, AB equals AE. So here there's a triangle BAE and A is an obtuse angle. It's given AB equals AE. Now it says the point C lies on BE, that means on this line, such that AC and BC both are equal. So AC and BC. So here I'll put somewhere here AC and BC. So these two lengths are equal. And it says the bisector of the interior angle CAE. CAE. So the bisector meets BE at D. So here I'll take another color. The bisector of CAE angle. So we'll draw the bisector here. Meets BE, that means this line at D. So this is the D point. So we'll mark it. This is the bisector. So this angle is equal to this angle. Illustrate this information in a figure. And the second part it says ABC is 40. If ABC is 40, this angle is 40. find the magnitude of DAE. So DAE angle. So we need to find out this angle. We'll put X here. Now look at the diagram. We know this is 40. That means this should be 40. Why? It's given AC and BC are equal. So that's an isosceles triangle. And here again we know this side is equal to this side. So if this is 40, this should be 40. That's also property of an isosceles triangle. So now look at carefully. So we know this is 40, this is 40. So what is this angle? This angle is the sum of opposite interior angles. So this becomes 40 plus 40, that becomes 80. Now we can consider the smaller triangle. We can write the sum of these three angles add up to 180. So we can write 80 plus 40 plus, we'll take the whole thing is 2x. If one angle is x, whole thing is 2x. That's equal to 180. Now we'll simplify. You get 120 here plus 2x equals 180. 2x equals 180 minus 120. So you get 60 here. If 2x is 60, what is x? 60 divided by 2, that's equal to 30 degrees. So what is DAE angle? So DAE angle is equal to 30 degrees. Now we'll look at what are the properties of isosceles triangles. Now in your textbook, example 1 is mentioning all 4 properties. So now we'll see what are the properties are. So here we'll take ABC triangle. And it says AB and AC lengths are equal. So that's an isosceles triangle. What is the first part says? The perpendicular drawn from A to BC. From A to BC, the perpendicular drawn. If you take that perpendicular, that's part 1. Part 2 says, if you get ABC triangle, ABAC equal the bisector of the interior angle BAC. So BAC, when you take the bisector, this angle is equal to this angle. So we'll take AD again. And the third part says, when you take the triangle ABC, and if you take the line joining A and the midpoint of BC. So if you take the midpoint of BC, if these two lengths are equal and this is also equal, when you connect that line, we'll take this also AD, and the other fourth part it says, if there's a triangle ABC, the perpendicular bisector of BC. So what is perpendicular bisector means? This is equally divided as well as this becomes a 90-degree angle. So if this happens, now what you can observe, we can see all these ADs coincide each other. So here basically if you draw the perpendicular from A or angle bisector or connecting the point to the midpoint or the perpendicular bisector, all are the same. So these are the properties in isosceles triangle. And another thing you need to remember, when you find the intersecting point of the equal side, we call this point as the apex. So you will get a new term. So what is apex means? The intersecting point of the two equal sides. So now we can use these properties in calculations. Now we'll take example number 2. So it says AB, AC in the triangle, both are equal. So we'll take a triangle ABC. AB is equal to AC. The side BA, that means this side, has been produced to E. So I need to erase this one because I don't have enough space to draw it. So I'll draw somewhere here. There's a triangle ABC and AB is equal to AC. The produced BA means you're extending this line to E. So if we take this one is E, the angle CAE is bisected by AD. So what is bisected means? The angle bisect each other. So this angle is equal to this angle. So that becomes AD. So this point is A. Prove that AD and BC, these two lines are parallel to each other. So you need to show that this line and this line both are parallel. So to do that, we need to take some values. Now here we can say if this is x, what is this value? This is also x because we know AD is the bisector of CAE angle. If this is x, 2x for the whole angle, what is the sum of these two angles? I'll put y here because these two sides are equal. So here you can say 2y is equal to 2x. Sum of opposite interior angles add up to the exterior angle. So when you divide by 2, we can say that y is equal to x. So what is y and x? Y and x, we can take, these are alternate angles. If these alternate pair is equal, that means we can say BC and AD lines are parallel. So here we can say DAC angle is same as ACB angle. So these are alternate angles. So therefore, we can say AD is parallel to BC. Now we'll take the third example. Now here it says in the triangle ABC, we'll try to draw that first. In triangle ABC, AB equals AC. The points P and Q lie on the side BC and such that BP and CQ. So here both are on the points PQ lie the side BC. So both points on BC line. So here the condition is BP, if it's P here, BP and CQ. So we'll take Q as this one. These two lengths are equal. Prove that APB triangle, APB, we'll connect that, and AQC triangle. So this is the other triangle. So here you get two lines here. So you're asked to prove that these are congruent. So we'll try to prove that. So I'll take another color. Okay, so here I can mark what we know. So these two sides are equal. So this angle is equal to this angle. So that's all we know, and these two lengths also equal. So now we'll try to prove. So what you need to prove? APB triangle and AQC triangle both are congruent. When you take these two triangles, we can see that AB is equal to AC. That's given. And also, we know BP is equal to QC. That's also given. What can you say about the angle? ABC and BP angle is same as ACQ angle because this is a isosceles triangle. Now we know two lengths and included angle given. So this is an included angle. So what can you say? We can say these two triangles are similar. So therefore, APB triangle is congruent to AQC triangle. Now that's the first part. Now the second part says APQ angle. APQ angle. So this is this one. We'll mark it like this. And AQP. AQP angle equal. So how can we say that? We know these two triangles are congruent. So we can say the corresponding elements are equal. So from the first part, we can say AP equals AQ. Those are the two corresponding elements. If you know these two lengths are equal, APQ is an isosceles triangle. Now what can you say about this isosceles triangle? If these two sides are equal, we can say opposite angles are also equal. So therefore, we can say APQ angle should be equal to AQP angle. Now we'll look at the exercise 9.2 in your textbook. So in the first question it says, based on the information in the figure, prove that ABC plus ACD is 180. So let's see what is ABC, this angle. What is ACD? This angle. And you are asked to prove that this plus this becomes 180. So we'll take this angle, okay? So ABC angle. That should be equal to this angle. Why? This is an isosceles triangle. So we can say that is equal to ACB angle. Okay, so here we can write what is this angle, ACD. ACD angle is 180 minus what? 180 minus this angle. So ACB angle. But we can write down this is 180 minus ACB, or you can write same thing as 180 minus, instead of ACB I can write ABC. Now what can I say now? When you take ABC angle to this side, I can see ABC angle plus ACD angle should be equal to 180. Now we'll look at the second question. In the figure, AB is equal to BC. So this side and this side equal. AD is parallel to BC. AD is parallel to BC. So in this triangle, we can see this length is equal to this one. So if we put X here, this is also x. Why? This is an isosceles triangle. So you can write CAB is equal to BCA because of isosceles triangle. Now we know these two lines are parallel. So here, because BC is parallel to AD, we can say this is also x. Why? Those are alternate angles. So we can say BCA angle is equal to DAC angle. Those are alternate angles. So what can you say? Now we found out. Therefore, DAC angle is same as BAC angle. So that means AC is the bisector, is the angle bisector of DAB. We'll take the next question. In question number 3, so you have given ABC is a straight line and some sides are equal. You are asked to find out BAE angle. BAE angle and BCD angle. This angle, when you add it, what's the value? Now, the other information given is these two are parallel. What can you say about the angles inside when you have parallel lines? We can say these are opposite interior angles. So here when you get two parallel lines like this plus this, opposite interior angles inside parallel lines add up to 180. So we can use that property. So we can write EAC plus EAC, or I can write BAE. So instead of this I can write BAE angle plus BCD angle should be equal to 180. What's the reason? Opposite interior angles add up to 180. Now we found the first part. So what's the second part? I'll write here A and B. A plus B is 180. That's the theory part. Now we'll take the second one. It says show that DBE, this angle is 90 degrees. So to show that, we'll take some values. Now we know these two lengths are equal. So we'll take this is as x, this is as x. We'll take this triangle, this is y, this is also y, because those are isosceles triangle. So what can you say about this angle? So we can write EAB plus BCD. We found that's 180 now. But how can you write this one as in terms of x? I can write this one as 180 minus 2x because the sum of angles add up to 180. How can I write BCD in terms of y? I can write 180 minus 2y. So it's equal to 180 from the first part. So here I can see 180 get cancelled out. So what you get here? 180 is equal to, take these two terms to the other side, you get 2x plus 2y. So when you divide both sides by 2, what you get? 90 equals x plus y. So what is x plus y means? Can you see? This is x, this is y. So these two angles add up to 90. But we know this is a straight line. So this angle is a straight angle. So what can you say? X plus y plus the required angle EBD should equal to 180 because that's straight angle. So we found x plus y is 90 degrees. So 90 plus EBD angle is 180. Now take it to the other side. We get EBD angle is 180 minus 90. That's 90 degrees. Now we'll take the fourth exercise. D is the midpoint of the side BC of the triangle ABC. So we'll try to draw the diagram. ABC triangle is there. The midpoint of BC. So D is the midpoint. So we can mark these two sides are equal. If BD is equal to DA, so when you connect A and D, it says BD is equal to AD. Prove that BAC is a right angle triangle. BAC is a right angle triangle means one angle should be 90 degrees. Now how can we find out? We can use, if this is X angle, what can you say about this one? This is also X because this is an isosceles triangle. If this is X and X, what can you write about this angle? These are the opposite interior angles to this exterior angle. So what can you say about this? This becomes 2x. We know if this is 2x, what should be this one? We'll write A and A because these two sides are equal. Now we'll try to find out the connection between A and X. In this triangle, we can write A plus 2x is equal to 180 because the angle sum of a triangle. So here 2a plus 2x is equal to 180. So when you divide both sides by 2, you get a plus x becomes 90 degrees. So what is a plus x? Can you see? This angle, one of the angle in ABC triangle is a plus x. Now we got that's 90 degrees. So what it means? We found BAC triangle is 90 degrees. That means one of the angles in a triangle is 90 degrees. So we can say ABC is a right angled triangle. Now we'll look at the fifth question. So there's an ABC triangle. It says AB is equal to AC. The points P and Q and R lie on the sides AB, BC and AC respectively such that BP is equal to CQ, BQ is equal to CR. So here, where is P point? That's on AB side. So I'll take a different color and mark P somewhere here. And Q lies on BC, somewhere here. Then R lies on AC. We'll take somewhere PQR. Now what it says? BP, this length is equal to CQ. So this part I'll mark with this colors. This length should be equal to this length. BQ is this length. So I'll take another symbol. BQ is equal to CR, this length. So here draw a figure with this information included in it. So this is the diagram. Prove that BPQ, so you have to take this triangle and QRC, that means this triangle. So we need to show that these two triangles are congruent. So we'll take those two triangles first. PBQ triangle and QRC triangle. Now we know in these two triangles BP is equal to QC. That's given. What else given? We know this side is equal to this side. So this angle should be equal to this angle. So what can you say? PBQ angle is equal to QCR angle. So because of isosceles triangle. And also there's another information. BQ is given CR. That's also given. Now we have two lengths and one angle. Now see whether this is the included angle. Yes, to these two sides, this is the included angle. So this becomes the included angle. So therefore, what can you say? So here, what can you say about this? Two lengths and one angle given, and this is also included angles. So therefore, we can say PBQ triangle is congruent to QRC triangle. Now, what's the next part? Prove that QPR. Now, we'll take the same another diagram. It's not clear otherwise. So we'll take the same diagram again. Now we'll take the other measurements. P, R, Q there. Now what's the second part says? Prove that QPR angle is equal to QRP angle. So here, from the previous part, we found out these two are congruent triangles. If these are congruent, what are the corresponding elements that are equal? We can see opposite to this double line angle is PQ. We can say PQ is equal to, opposite to double angle is QR. So we can see this PR length and this length both are equal. So when you look at this diagram, this side is equal to this side means we can definitely write down QPR angle is equal to QRP. What's the reason? This is an isosceles triangle. So here you have to write down the reason for this. This is because of corresponding elements. Now we'll take sixth question. In the triangle ABC, B is right angle. So we'll draw a right angle triangle. A, B, C. This is right angle given. BD has been drawn perpendicular to AC. So here perpendicular to this. So we'll try to draw the perpendicular line, that's BD. The point E lies on AC, that means on this line, such that CE is equal to CB. So we'll take any point here E. This whole distance we'll mark like this. This whole distance is equal to this distance. So here this and this both are equal. So draw a figure with the information included in it. Prove that ABD is bisected by BE. So that means if you draw this line BE, you have to show that this and this both angles are equal. So how can we do that? So we need to take some letters. Now here, if you think about this triangle, BEC triangle. When you take BEC triangle, can you see CE and BC both are equal? It's given. So if these are equal, what can you say about these two angles? So I can say this angle is equal to this angle. So I can write BC angle is same as BEC angle. Why? Because of isosceles triangle. Now, what's the other information given? So we know, we'll put X as this. So this is also X. Now, if this is X, what is this angle? What is this part? We know B angle is 90. So this becomes 90 minus X. If we put this one as Y angle, from this triangle we can easily find out the Y value. So what is Y? We can say Y plus X plus 90 is 180 because this is the sum of angles in BED triangle. So what is Y? Now take 90 to the other side. 180 minus 90 is 90. Y plus X is 90. Y becomes 90 minus X. So what can you see? You found this angle is also 90 minus X. This also 90 minus X. So you can write down ABE angle is same as EBD angle. So what can you say about that? If these two are equal, that means BE is the bisector of ABD angle. So that's what we need to find. Now we'll look at 7th question. 7th question, it says prove that the angles in an equilateral triangle are 60. So we'll try to prove that. So equilateral triangle, so you have to know these are equal. All sides are equal. Then what can we do? We can take, if, look at this way, if this is this side, AB is equal to BC, what can you say about these two angles? These two angles are equal according to isosceles triangle. So we can write A is equal to C angle because of isosceles. Then think about the other way. So if AB equals to AC, what can you write? If this side is equal to this side, this angle is same as this angle. So here if this is happening, so you can write C angle is same as B angle. So can you see by looking at these two? What can you say? C angle is equal to A angle. Again, C angle is equal to B angle. So that means A also equal to B. So we can write therefore A angle is equal to B angle is equal to C angle. If all three angles are equal, we'll put X here. We can say 3x is equal to 180. Because the angle sum of a triangle is 180. So what is x? 180 divided by 3. So you get 60 degrees. So what is x? X means one angle of ABC triangle. Now we'll take example 1 in your textbook. So it says you have given a triangle. Find the equal sides of the triangle ABC. Now this is 50 given and this is 80 given. So you have to find out the other angle. How can we find out the other angle? So BAC angle is equal to 180 minus the sum of the other two angles. So what's that? 180 minus 50 plus 8 is 130. So you get 50 degrees. So we found this is 50 degrees. Now look at carefully. This angle is equal to this angle. So according to the converse of isosceles triangle, what can you say? We can say AC is equal to BC. So this is converse of isosceles. So we'll take the second example. Based on the information in the figure, show that AC equals AD. So where's AC? This line. AD is this line. So we need to show these two lengths are equal. So we'll try to find out the angles. Now we'll try this angle. To this ABC triangle, we can see this is the exterior angle. So what can you write about C angle? So ACD angle is 60 plus 25 because of exterior angle. So what's the value? You get 85. What can you see again? So here AC, you have to show AC equals AD. And also you can find this angle. How can I find CAD angle? We know 95 is the exterior angle to ACD triangle. So we can do CAD angle is 95 minus 85. So what's the value? You get 10. Now this is 10 we found. This is 85. We can find this angle. So what's that angle? You can do ADC angle is 180 minus these two, or can you see this is a straight angle? You can straight away subtract from 180. So 180 minus 95. So what's the value? You get 5, 10, 8. So you get this is also 85. According to the converse isosceles triangle, these two angles are equal. So what can you say about the opposite lengths? We can say AC and AD should be equal. Now we'll look at example number 3. In the square ABCD, the points P and Q lie on the sides AB and AD respectively such that the angles are equal. Prove that BP equals QD. So we'll try to draw the diagram. This is about a square. Draw a square ABCD. You can mark all sides are equal and all angles are 90 degrees. The points P and Q lie on the sides AB. So somewhere here P on AD. AD is, Q is on that line. Such that QPC. So here I'll take another color. QPC, this angle is equal to PQC. This angle. So it's given these two angles are equal. So prove that BP, that's this length, is equal to QD. So these two lengths are equal. So what can we do? We can see from PQC triangle. These two angles are equal. So that means the opposite lengths should be equal to each other. So we can say QC should be equal to PC because this is an isosceles triangle. Now if you take the two triangles, these small two triangles, BPC triangle and QDC triangle, what can you say? I can say QC is equal to PC and CD equals BC, and what else? This is right angle triangles. So we know the hypotenuse and one side equal. This is a right angle triangle. In a right angle triangle, hypotenuse is this one. And this is one side. If you know one side and hypotenuse both are equal, we can say PBC triangle is congruent to QDC triangle. And if these two are congruent, what can you say? Corresponding elements are equal. So what are the corresponding elements? The third length. So here the third length QD should be equal to PB because these are corresponding elements. And also you need to identify what is this, what is the case we used? RHS. What is RHS? Right angled hypotenuse side. Exercise 9.3 in your textbook. So in this question, so we need to select what are the isosceles triangle in these diagrams. So we'll see from the angles. So here x, y, is x. Here these two angles are equal. So if these two angles equals means opposite sides are equal according to the converse isosceles triangle. So what can you say? Two sides are equal. So this is an isosceles triangle. Look at this one. This angle is equal to this angle. So that means these two sides are equal. So if two sides are equal, we can say ADC triangle is also isosceles. What about this one? This angle is equal to this one. So definitely we can say AB and BC are equal. So ABC also isosceles triangle. What about the other one? This one you have given, this is 45 and we know this is 90 degrees. So easily we can find out this angle. 180. 45 plus 90 plus this angle is 180. Or you can say 90 minus 45. So definitely this becomes 45. What else we can find? This is 45, this is 90. So this should be 45, and if this is 90, this is also 45. Now look at carefully, what are the angles equal? We can see these two angles are equal, so this side should be equal to this side. And in this triangle, these two angles are equal, so we can say SQ and SR both are equal. So what can you say? What are the isosceles triangle? We can say PQS triangle and QSR triangles are isosceles. Now we'll move to the next part. So in this question, you have given KN and LM both are parallel and KL and NM also parallel. So here, what can you say about this? If this is 40, this is 40 because of alternate angles. If this is 40, this is also 40 because of alternate angles. What can you say about this triangle? This side is equal to this side. And also we can see this is a part of a parallelogram. What is this shape? And also we can see these all angles are equal. This is also equal to this one. So this is actually a rhombus. So how can we find out what are the isosceles triangle? We can see KNL triangle and LMN triangle, both are isosceles. Now we'll move to the fifth part. So here you can see opposite sides are parallel. This is a parallelogram. What can you say about opposite angles? Opposite angles are equal in a parallelogram. So straight away you can write this is equal to 110. If this is 110, what can you say about this angle? These two add up to 180. So what can you say about E angle? So BE A angle is 110 minus 70. So what is 110 minus 70? 40 degrees. Now we can find this is 40. What about this angle? 180 minus 110. So this becomes 70 again. So what can you say about that triangle? BEA triangle is an isosceles triangle. Now we'll move to sixth part. So look at carefully. This angle is given x and this angle is given. So definitely this is an isosceles triangle. So here we can write ABK is an isosceles triangle. So what else? When you look at this one, this and this also equal. That's also isosceles triangle. So we can write KCD triangle is also isosceles. Now when you take this triangle, what can you say? This is 2x because of exterior angle. This is also 2x. You get these two lengths also equal. So what is the other isosceles triangle? You can say BKC also isosceles triangle. So here, what can you say? All these three are isosceles triangles. Now we'll look at question number 2. So you have given a triangle ABC. It says ABC, this angle, BCA, this angle, and BAC, this angle, all are equal and prove that this is an equilateral triangle. So how can we prove that? If these two are equal, we can say this length is equal to this length. That is isosceles triangles. If when you take other way around, if B angle is equal to C angle, that means this side, these two sides should be equal. So that means all these lengths are equal. So here, if this is equal to this one, we can write, I'll write these two equal means I can write AC equals A and B, AC equals BC. If these two angles are equal, B and C, I can write AB equals AC. Now can you see? From these two equations, I can write AC is equal to AB equals to BC. All three sides are equal. And also we can see all three angles are also equal from this one. So if this is equal, we can say A angle equals B angle equals C angle. So what's the value? If we put x as the angle, we can say 3x is equal to 180. X becomes 180 divided by 3. You get 60 degrees. So here we can prove that this is an equilateral triangle. Each angle is 60 degrees and all sides are equal. Now we'll look at the third question. Now here you have given a triangle ABC and ABAC both are equal. The bisectors of the angles ABC, that means this angle should be equal to this one, and ACB, that means this angle is equal to this one. Prove that BOC in this triangle is an isosceles triangle. So we'll try to show that. So here we'll take ABC triangle. AB is equal to AC. So that means ABC angle is equal to ACB angle. These two are equal. So if these two are equal and this is bisector, so what can you write? If this whole thing is 2x, this is also 2x. But we know this is bisector, so this is x, this is x. So this is also x, this is also x. So we need to prove that BOC is an isosceles triangle. Now look at carefully the BOC triangle. What can you say? BOC triangle. OBC angle is same as OCB angle. That's x. So two angles are equal. That means OB is equal to OC because of converse isosceles. So we can say OBC is an isosceles triangle. We'll take the fourth question. In the figure, it says AB and AC both are equal. BC and PQ are parallel. Prove that AP is equal to AQ. Okay. So we'll first mark the given information. So this side is equal to this side. And these two lines are parallel. So you are asked to show AP is equal to AQ. So we'll take angles. Now we can say if this is x, according to the parallel lines, this is also x. Why? Corresponding angle. So we can write APQ angle is equal to ABC angle, corresponding angles. What else we can say? We can write this angle is same as this angle. So here we can write AQP angle is same as AQB angle. That's also corresponding. And also we know ABC triangle, AB is equal to AC. So that's an isosceles triangle. So what can you say about x and y? X equals y, because ABC is an isosceles triangle. So we can say ABC angle should be equal to ACB angle. That means x and y. So here this is y. So that means x equals y. What can you say about that? So if these are equal, now we'll take the small triangle. These two angles are equal. That means these two lengths should be equal. So the first part, if APQ is an isosceles triangle, we can say AP equals AQ. What's the next part? You are asked to show BP is same as CQ. We know, we'll do the second part. We know AB is equal to AC. And also we know AP equals AQ from the second part. We'll subtract these two. 1 minus 2. So what you get? 1 minus 2 becomes AB minus AP is equal to AC minus AQ. So what is AB distance minus AP? You get BP. What is AC minus AQ? You get QC. So these two should be equal. Now we'll take the fifth question. So in this triangle, D lies on the side AC. It's given and such that BAD, this angle is equal to DBA. So already marked there. And also ABC is 90 degrees. So this is 90 degrees. Prove that DBC is this angle and DCB, this angle, you have to show that these two are equal. So how can we prove that? We can use a letter. We'll take x as this, then this is also x. What about this angle then? This is equal to 90 minus x. So we can write ABD angle is x and BAD angle is x. So here we can write DBC angle is 90 minus x because the full B angle is given as 90 degrees. Then if you take the full triangle ABC, what can you say about this angle? We know this is 90, this is x. So what is ACB angle? So we can see this angle is 180 minus 90 plus x. So when you do the calculations, 180 minus 90 becomes 90 and you get minus x. So can you see? You get this angle is same as this angle. So we can write therefore according to this and this one. What is ACB? ACB you can write as DCB. So this is same as DCB. So here according to these two, what we can write? DBC angle is same as DCB angle. So that's the first part. Now we'll take the second part. So when you look at the triangle, now we have to show that D is the midpoint of AC. So that means we have to show that this distance and this distance both are equal. Now how can we do that? Now can you say when you take BDC triangle, this length is equal to this length. So here we can write BD is equal to CD. Now when you take ABD triangle, what can you say about BD and AD? Both are equal because that's also an isosceles triangle. So this is because of isosceles triangles. So now look at these two, 1 and 2. We can say CD is equal to AD. So this distance is equal to this distance. That means D is the midpoint of AC. Now we'll do the sixth question. So it says the bisectors of the angle B and C of the triangle ABC. So that means we'll take the triangle ABC. Now in the triangle it says the bisectors of B and C meet at R. And also it says the BC and PQ both are parallel. So BC and PQ should be parallel and the bisector both bisectors meets at R. So this should be the diagram and this angle is equal to this one because this BR is the bisector. This angle should be equal to this one. So here and also these two lines are parallel. Now we'll try to answer the question. So it says prove that BP is equal to PR. So you asked to show this distance is equal to this distance. So we'll use some letters and try to find out. If this is X, this is also X. If this is Y, this is also Y. And also look at these two parallel lines. If this one is X, we can say this is also X. If this is Y, this is also Y. Now, to prove the first part, you need to think about this triangle. So, what is that triangle? BPR triangle. So, we can see PBR angle is same as PRB angle. That's X because of these alternate angles. Now, these two are equal means straight away we can write BP should be equal to PR. That's the converse isosceles triangle. Now, that's the first part. Now it says, prove that PQ. So, what is PQ? PQ. This distance is equal to BP. So, what is BP? this one plus QC. So here what we can do, we can write down what is PQ. PQ distance we can write PR plus RQ. But we know PR is same as PB because we proved in the first part. So instead of PR, I can write this is same as PB. Now here, what can we say? Now in this triangle also we can show that. So here we have to take separately RQC triangle and show that RQ is same as QC. Why? This is also isosceles triangle and these two angles are equal. So we can write this is isosceles triangle. Now instead of RQ, what can I write? I can write QC. So instead of this, I can write QC. So we can show that PQ is same as PB plus QC. Now we'll look at the 7th question. So it says in the triangle ABC, so we'll draw it. The point P lies on AC, so somewhere there such that ACB angle is equal to ABP angle. So here if you draw this one somewhere P, this angle and this angle both are equal. The bisector of PBC bisector, so we'll take another color. Bisector of this meets the side AC at Q. So this point should be Q. Prove that AB equals this length is equal to AQ. So this length. So we need to show this length is equal to this length. Now we'll look at the diagram and we can use different letters and see. So it says these two angles are equal and the bisector. So we will put X here and X here because this is the BQ is the bisector of the angle B. Now if this is 2, this one will take Y, then this also becomes Y. Look at this triangle BQC triangle. This is X and this is Y. What can you say about this angle? AQB triangle. We can straight away write down this is X plus Y because of exterior angle. And what about this angle? ABQ angle. That's also X plus Y. Now, what can you say about these two? Both are X plus Y. So, you can say ABQ angle is same as AQB angle. When you take ABQ triangle, we can see this length is equal to this length because of these two angles. So therefore, you can say AB should be equal to AQ because of converse isosceles triangle. We'll take the next question, question number 8. So it says it's a quadrilateral PQRS and PQ is equal to SR and the diagonals PR and QS, which are equal in length, intersects at T. So we'll try to draw the diagram. So we'll take P, Q, R, S. So here we'll take P, Q, R, S, something like this. It says PQ is equal to SR. And what is given? It's given if you draw the diagonals, these two, this is intersects at T. And these two lengths also equal. So this length, I'll take another color. This length is equal to this length. Now what you have to prove? So you have to prove PQR triangle is congruent to SQR triangle. Now we'll look at those two triangles, PQR. So we can say in PQR, PQ is equal to, in this triangle, that's equal to SR. And also in that triangle, we know that QS is equal to PR. Now you can see QR side is common. Now what can you say? All three sides are given equal. So that means we can say these two triangles are congruent. What's the case? We can say side, side, side. So we can say these are congruent because of side, side, side. So here now we have to show that second part, QT equals RT. So what is QT? This length. I'll put a question mark, and RT. So this distance. Now we'll do the second part. So we are asked to prove QT, this one, is equal to TR. So what can we do? Now we found out these two triangles are congruent. So if these two are congruent, corresponding elements are equal. So what can you say about this one? So here we can say if you take PQR triangle, opposite to this line, this is the angle here. So we can say PRQ angle is same as, what's the other angle? Opposite to this angle. So that's Q angle, SQR. Now we found out these two angles are equal. So now if you take TQR triangle, we can see this is an isosceles triangle. So if this is isosceles triangle, what can you say about the sides? We can say QT is equal to TR. Now we'll take ninth question. In the triangle ABC, it says AB equals AC. So we'll mark this. The bisectors of ABC and ACB meet at O. So that means this angle is equal to this angle. Now what can you say about the whole B angle should be equal to C. So we can mark this angle is also equal to each other. So the question asks, BOC is an isosceles triangle. BOC is an isosceles triangle. Okay, we'll try to prove that. Now we have to write AB equals AC, that's given. So because of that, ABD angle should be equal to ACD angle because of isosceles triangle. And it says these are bisectors. So here we can say if this is X, this is also X, this is also X, This is also x because of bisectors. So what we can write? We can write OBD angle is same as OCD angle. That's equal to x. Now we can see when you take OBC triangle, these two angles are equal. So this is an isosceles triangle. So we can straight away write down BOC is an isosceles triangle. Now what's the second part? The first part, it says AOB triangle. AOB triangle and AOC triangle are congruent. So we'll take those triangles AOB and AOC triangle. These are the triangles that we need to check whether these are congruent. So AOB, when you take AOB triangle, we can see ABO angle is same as ACO angle. ACO angle, that's x. And also AO is common to both sides. Now we can see from the OBC triangle that we found that's an isosceles. So OB length is equal to OC. Now what can you see? Two lengths and one angle. Now check whether this is the included angle. Yes, this and this is the included angle. So when this is included angle, you can write down these two are congruent triangles. So we can write therefore AOB triangle congruent to AOC triangle. Now we'll take the third part. So when you take third part, it says show that AD is perpendicular to BC. So here we need to find these two angles are equal. So we'll take the two triangles ABD and ADC. When you take those two triangles, we'll see whether these are congruent. So here we can say AB length is equal to AC. And what else? We know that this angle is equal to this angle. And also we can see AD is a common side. Here now we need an angle. So how can we find out an angle? Now in the second part, we found that these two triangles are congruent, AOB and AOC. If these two are congruent, what can you tell about these two angles? These are corresponding elements. So we can write BAD angle should be equal to DAC angle because of corresponding elements. Now we have two sides and one angle, and this angle is the included angle to these two lengths. So what can you say? This is also included angle. So we can straight away write down ABD triangle is congruent to ADC triangle. Now if these two are congruent, what are the corresponding elements? We can say this angle is equal to this angle. So we can say ADB angle is equal to ADC angle. If we put x for each, we can say this is a straight angle. 2x is equal to 180. X is equal to 180 divided by 2, 90 degrees. So that means we can say this is 90 and 90. That means AD is perpendicular to BC. 10th question. It says a circle of center O is given in the figure. Show that BOC, that means this angle, is double of BAC. BAC. So we'll take this one is X and you have to show that that's the double of that. So what can we do? We know this is a circle. So we can mark all the given information. So the O is the center. So that means OB, OC and OA all are radius. So we can straight away write OB is equal to OA is equal to OC, all radius. Then what can you say? When you take AOC triangle, we can say OA is equal to OC. So that is an isosceles triangle. If this is X, I can write this is X. So I can write OAC angle is equal to OCA angle. That's, I marked it as X. Now look at carefully. So what is this angle? This angle is the exterior angle to AOC triangle. So I can write BOC angle is equal to sum of interior angles, sum of opposite interior angles. So that is OAC plus OCA. But we found out this is X, this is also X. X and X becomes 2X. So what is X there? We took as OAC angle. So what can you write? BOC angle is twice as BAC angle. So what is BAC means? Same as OAC. So we can write twice of that. So we covered all the exercises and examples in this chapter. So what are the theories we learnt in this section? Mainly we learnt about isosceles triangle. So what are the theorems we learnt? We learnt about first theorem is when two sides are equal, the opposite angles also equal to each other. And what is the converse theorem to isosceles triangle? When two angles are equal, the opposite sides are also equal. So here, remember those theorems and you can apply in triangles.